Hi everyone. In this video, I'm going to explain about what is convert map. K-map gives a systematic approach for simplifying any Boolean expression. The basis of the method is a graphical chart known as K-map, and it contains the boxes called cells. Each of the cell represents one of the two different possible products that can be from n variable input. This is an example of a four variable K-map, and a four variable K-map means it having the total of two or four boxes. These boxes is called as cells. So the four variable K-map can be represented like this. For example, the function is called f of a b c d. So we are putting a b c c d in the form here shown in figure, and this is the 2 power 4 total of 16 boxes are available. So the rows and columns are divided like see this in AP form. The columns are represented like this. This is 0 0 0 1 1 1 and 1 0. So we are representing like this. Here in row wise is also we are representing CD in the form of 0 0 0 1 1 1 and 1 0. And what about these boxes means this represents the minterms of the four variable K map. So for example, this A, B and C, D, this is 0 0 0 0. That means this represents the M0, and this one is nothing but a M1. 0 0 0 1 is nothing but a minterm of M1, and this one is 0 0 1 1 is nothing but a minterm of 3. Like that, we are representing all the cells in the form of a minterms. For example, if you consider this one, this is from row wise, this is 1 1, and the column is also 1 1. So this represents the number 1 1 1 1. It is nothing but a minterm of 15. So that's why it is called a M15. So these minterms are representing using the minterms A bar, B bar, C bar, D bar. This one is A bar, B bar, C bar, D bar, like that. If you consider this one, this is nothing but A, B and C. So like that we are representing the cells. And this is an example. Solve the given K-map. The step 1 is nothing but a grouping. How we are grouping the cells, and second one is output of the each group, and step 3 is a final output, and the answer is like this. So see, the ones represented is nothing but a given Boolean expression. That Boolean expression having the minterms called 2, 3, 4, 6 and 10, 11, 12 and 14. So these are nothing but a representing using ones. So how can we map these ones means? So we can map adjacent cells that is in the form of a 2 or 4 or 8 like that, or 16. We can map adjacent cells. For example, here if you consider, we have all 4 ones is there, so we are grouping these 4 ones like a single one, and the top two, these two, and the bottom two is also it's a side by side adjacent cells. So we are mapping top these two like this, and the bottom one is like this 4, and this one here 1 1 and here 1 1 is there. So we are mapping the adjacent sides, the corner sides is also like that. So if you solve this one after grouping, so the expression is like that: C D bar plus D bar C plus B D. K-map for sum of products minimization. The K-map is used for simplifying a Boolean expressions to the minimal form, and the minimum is sum of products expression contains the fewest possible terms with the fewest possible variables per term, and generally a minimum sum of products expression can be implemented with few logic gates than a standard expression. See this one. It is an example of how to group the cells. So we can group cells like adjacent like this one and this one. But here we need to consider only the minterms. So wherever we have the ones, those ones only we are considering. That is called a minterms. Otherwise, we can consider in the form of a max terms. If we can consider a zeros also. If they are asking in the form of a max terms, we can map only zeros. But here it is an example of a minterm. So this one and 1. So we are mapping the adjacent ones like this. This is the right method, and this 0 and 1 is the wrong method. We can't group to 0 and 1. and the diagonal ones also we can't map. So we can map like this, we can map adjacent like this one, and we can map in the column wise also, and the diagonal ones cannot be grouped here. And this is an example of how the minterms are mapping a group of 2. And see, it is not possible to map the cells 3. Group of 3 also not possible. This is a wrong mapping. And 4, we can map all the 4s at once like this one. And we can't map all zeros and ones simultaneously. So if we have like this, we can map these upper 4 as one group, and these 2 are one more group like that. We can't map these one. And minimum group should be formed like this. So if we have the minterms like in these cells using the 3 variable k-map, we can map all the top 4 as one group and these 4 as a one more group. And see, we can't map like this. If we have the all 4s in the top and this one, we need to map. We need to group the cells. The maximum number of cells should be grouped. We can't take a minimum or we can't take an individual. If the possibility is there of a grouping a 4 cells, we need to group 4 cells. We can't group 2 cells and 2 cells like that. If we are grouping like that, we are getting the more number of minterms. The expression should be more complex. The main advantage of using this K-map is to minimize the given Boolean expression. So this one is right one. We are mapping this top 4 and this 4 we are mapping. So we can use already mapped ones also. We can use for unmapped ones, but we can't map already covered minterms. Again, we need not to map. For grouping individual minterms, we can use the already existing cells also. We can map like this. So this is one more. See this one, we have the all 4 1s and 4 1s here. So here we can map this rightmost these 2 and the leftmost these 2 at a time, like using grouping a 4 cells. And again we can map like this top 4 1, and again we can map these 4 1 like this. So this is how we can map the cells. This is the nothing but an example of how we can use the 3 variable k-map. And this is how to map, how to represent the Boolean expression using minterms in the 3 variable k-map. And this is how can we combine the adjacent cells using 3 variable k-map. If we have 1 1s like this, we can map like this one. And if we have 1 1 here, we can map like this. If we have 4 adjacent cells, we can map like this. If this is a top 4, we can map this top 4 1 like that. And this one is side by side, we can map. And we have the corner at the corner of these 2, we can combine these 2 as a single one. And the top one is also. If you have all the corner, we can map like this. And this is how to map a 4 variable k-map. If we have top 1 and bottom 1, so we can map these 2 as a grouping, and in middle one also. And this one, if we have the second row at the corner side, we can map these 2 also. We can map 4s, all 4s adjacent, and we can have the same rows in the corner. We can map this one is as a 4 grouped cells like this one. And all the corner ones is also available. We can map this is all 4 corner cells is as a group 1. So this is also an example. If we have not possible to combine any grouping in the cells, so we can take it as a single one like this. And if all the 4 1s here, left side and right side, we can map this is as a combination grouping of 8 cells. This is also grouping of 8 cells. This is also an example of a grouping of 8 cells. This one top and bottom cells. This is an example of how can you can solve the given expression using the 4 variable k-map. This is a 3 variable k-map. How to combine these 3 variable k-map using the given expression. And by using also truth table also, we can consider as a k-map. For example, we have the inputs called ABC, and the ABC have the output with the x value, and whatever we have the ones here, so these we are taking as a min terms. For example, in the 0 location it is the 1, so it is nothing but a min term of m0, and this is 4, and this is 6 and 7. So in that locations we are marking these ones, and we can map the 3 variable k map, like this top one and bottom one as one group, and these two as one more group. Thank you.